So our first question here, in October 25 cars were sold from the garage. We need to complete the pictogram for October, but because I can see over here we have got that a double box represents 10 cars. I know that one box is going to represent 5 cars, so I've got 2 full sets of boxes and a single box. For part B, compare the number of cars sold from the garage in August to the number of cars sold from the garage in September, and we've got to give a reason for our answer. I've put there were more cars sold in August with 35 compared to 20 in September. Because this is a 2-mark question, what is really important here is that we give your statement of more cars and then give the comparison as well. In terms of part C then, it tells us that in November 17 cars were sold from the garage. We need to explain why the use of this key may not be appropriate for representing 17 cars in the pictogram. Well, I've gone with the fact that numbers can only be accurately represented in multiples of 5, and 17 wouldn't match that criteria. Looking at question 3, we need to write down an estimate for the percentage of households with internet access in 2000 and in 2018. We're using the graph. 2000 is up here at 25 and 2018. We had to work a little bit harder to use the scale, but it was this value up here, so that was 90%. For part B, we had to plot the information on the time series graph, and that was that in 2019, 93% did have internet access, so that is what I have plotted up here. For part C, writing down the year where the percentage of households with internet access was first greater than 50. Well, if we read up at 50 and then go across, the first value that is above that is at 2005. Part D, it says, using the information given in the time series graph, compare the change in percentage of households with internet access in 2001 to 2005 with the change in percentage of households with internet access in 2015 to 2019. We must show how we get our answer, so we've got to do some mathematical calculations here. So all I've done, and you can see here, 2001 and 2005, I've put the values down, and the difference there is 19%. And then from 2015 to 2019, again, I've taken the data from the graph, and the difference is 7%. So the way I've written my answer here, as I said, that there was a 19% increase between 2001 and 2005, compared with a 7% increase between 2015 and 2019. Therefore, there was a greater increase between 2001 and 2005. You'll see I've made my decision as to which had the bigger increase. I've also stated the data that I used up here within my calculations. In question 5 then, we have to decide whether or not the mode would be the appropriate way of using this data, or whether there is a mode. And what we can see is all numbers, all values only appear once, so therefore there is no mode in this question. To find the median of my results, the first thing I needed to do was put them in order, and then what I've done is I've crossed one off from each end, and we get to that middle value, which leaves us with a median of 25 minutes for the time taken to change a tyre on these cars. For C, we need to show that the range of the results is 20 minutes. Well, to find the range, we do our biggest value, subtract our smallest. So I've got 35, subtract 15, which gives me the range of 20. For part D, they've told us that the range of the times that Jane took to change the oil in each of these 9 cars is 28 minutes. And then we're asked, are the times that Jane took to change a tyre on each of the 9 cars more consistent than the time she took to change the oil in each of these 9 cars? And we need to give a reason. Well, what I've looked at is we've got more consistent changing within the time it taken to change the tyres, because the range is lower, range being our main measure of consistency. In question 7, told Mrs. Singh is the head teacher of a school with 1,200 students. She wants to find out about the ways the students at her school use the internet to complete their homework. She's going to write a plan for her inquiry. We need to write down one thing that she should include in her plan for each of the following: data collection, choice of sampling method, and a diagram to represent the data collection. And we have to explain why we would use each. So for data collection, I suggest that you should use a questionnaire because it is an easy thing to get to all 1,200 students within the school. In terms of my sampling method, I've suggested a random sample so that all students within the school have an equal chance of being selected. And then in terms of representing the data, I have suggested a bar chart would easily show this information and be easy to interpret. One thing to mention on this question is there are lots of possible answers that you could have given. So in data collection, yes, we could have used a questionnaire, as I said, but you can see we could have used a tally chart or a table, we could have interviewed people. In terms of our choosing the sample, I said about the random sample, but we could have used a systematic sample because it gets every nth person in a large population. We could have used a quota, we could have used a cluster, we could have used a stratified sample. Each of these has their own individual strengths. And then in terms of the diagram, again, I've put about the bar chart. We could have used a pie chart as another example of a way of representing this data. So lots of possible answers you could have given here, but you need to give a reason with each of your suggestions. For question 9, we're told that Dylan investigates the ages of 150 people at a music festival. The youngest person at the festival is 21 years old and the oldest person is 68 years old. Dylan decides to use group frequency table to show his results. We need to give 2 advantages of using group data rather than raw data. So my first answer said that it's easier to process large amounts of data, and then secondly I've put that it's also easier to represent on graphs. We've been asked to then come up for part 2 of this, give 1 disadvantage of using grouped data rather than raw data. I've put you lose the accuracy within the data if we have group data, as we don't have the specific values. For part B of the question then, we've been told that Dylan is considering using one of 2 possible frequency tables, table A or table B, as we've got shown here. He's claiming that table B gives more detail than table A about his results. We need to assess whether or not Dylan's claim is appropriate. Now, I'm saying that there are smaller group widths in table B, which gives more detail to the person using this data. You can see we've got a group width of 10 in table B compared to 20 in table A. And one of my negatives with table A is they're saying that data has been condensed into 3 groups in this table. You can see that these values aren't being used. We've got everything condensed in here, which makes it harder to analyse. So overall, I have then made my decision that I believe that Dylan's claim is justified. Moving on to part C then, we have got that Dylan wants to work out the average age of the 150 people at the music festival, and he decides to use table B. We need to calculate an estimate for the mean age of the 150 people at the music festival and give an answer to 1 decimal place. So what I've done here is I've created a table and I found the midpoints for each of these group widths in table B, and then I've done my midpoints multiplied by my frequency. I've got my total. So for example here I did 25 multiplied by the frequency of 6, 35 multiplied by 67 to get these values in the table. I've totaled that up, which gives me 6,310, and because there's 150 people at the festival, I've divided that value by 150, which gives me 42.06 recurring. So following the question, it asked me to leave it to 1 decimal place, with 42.1 as my answer. On to question 11 then, and using this scatter graph, they've asked us to assess whether or not the vet's conclusion is accurate as to whether there is a relationship between the weight of the dog and its lifespan. I have agreed that yes, it does support this conclusion because it is showing a negative correlation. You can see in the graph there is a general pattern going down, that the less the weight of the dog, the longer it is likely to live. Okay, so part 2 here, it says assess the reliability of the vet's conclusion, and I've said that while yes we can see the correlation here as we've just discussed, it may be unreliable, and the reason I've gone for that is because they've only got the data from 10 breeds of dogs. There are obviously hundreds of breeds of dogs out there, and they've only taken data from a select group, so therefore it might be unreliable. On to question 13, and part A is asking us to write down the percentage of the population who are female in the age group 50 to 54. So just using the pyramid up here, 50 to 54, and then read across to female, which is the lighter side of the graph. We have got 3.7 as our answer. And then it asks us for part B to work out the percentage of the population who are male in the age group 10 to 19. So similar idea, 10 to 19. Now what you'll notice here is we've got 10 to 14 and 15 to 19. So I actually need to do my 2.8 add 2.9 and I get 5.7 as my answer. For part C, we're told in 2017 the number of people aged 100 and older in the United Kingdom was 13,310. It tells us to use the information above and the information supplied in the population pyramid to explain why the percentage of the population pyramid in the age group 100 plus is given 0.0% on the population pyramid, and like a question earlier, we have to show our working. So as I've done this question, I've taken the number of people that they've told us in the question here, and I've divided that by the total population within the UK, which is 65,511,097 people, and I've multiplied that by 100 to get 0.02. Now, what you'll notice from the pyramid is it has rounded everything to one decimal place, and that is why it would come up as 0.0 as our answer. As we move into part D, then we're told Jamie is carrying out research into the ages of people in the United Kingdom, and he uses the information in the population pyramid to claim that in the United Kingdom in 2017 the number of males who were older than 40 was greater than the number of females who were older than 40, and we need to explain whether or not his claim is correct. Now, I've looked at the pyramid, and what I've decided is every age group from 40 and over shows women have a higher percentage of the population, so therefore he has to be incorrect here. It does not support his claim. Finally, looking at question 15, we're told that the chloropleth map gives information about the numbers of orangutans living in the forests of the Malaysian state of Sabah in northern Borneo. Some regions of the state are shaded with and labelled with a number. Now that has been clearly shown there, and we've got the key here which we can use to analyse the map that they've given us. Part A says write down the number of a shaded region where there are not more than 100 orangutans. So that will be our lightest shaded areas, so that would give us number 1, number 2 and number 4. So that is the answer that I've put down here. And finally then for part B, we're told regions 15 and 16 are protected forest regions. Adam claims that in a protected forest region there is a greater number of orangutans. We're asked if the chloropleth map supports Adam's claim, and we must give a reason. Now I've decided that yes, it does support the claim, because those areas, so area 15 and 16, are the darkest regions on the map, which indicates that there are more than 1,500 orangutans in each of those areas.